Okay, hi everybody. So today you're going to take notes on percent of change and percent of error. You should have your notes page out, whether it is on as a document and you're going to type into it, or if you have it printed out and you're writing out, or you're going to write it on a piece of paper, whatever the case may be, but this is what it looks like. Okay, the first thing we're going to talk about is percent of change. The percent of change is the percent that a quantity changes from the original amount. We've been talking about percents, and we've been finding different percents. We've been finding sale, discount, markup, tax. We've been just finding percents of a number, or using part over whole or is over of, and all percents were out of 100. So you're going to see that the percent of change equation that we're going to use is the amount of change over the original amount multiplied by 100. So it's basically like when you get a score on a test. If you get a 45 out of 50, you can divide those two numbers and multiply by 100, and then you'll have your percent, okay? In this case, we're finding a percent of change. So the amount of change you're going to see is how much a number has changed. In this case, we're finding the percent that the number has changed. Okay, we're going to go into some examples that hopefully will explain that or help you understand that a little better. When the original amount increases, the percent of change is called a percent of increase. So if you start at 12 and you go up to 20, that would be an increase because you're going from 12 to 20, which is going up. If you start at 20 and go to 12, then the original amount decreases. That would be a percent of decrease because you went from 20 to 12, so you went down. Okay? Now, the next one is an example here. Okay, if you look at this example, you'll see the table shows the number of hours you spent online last week. What is the percent of change in your online time from Saturday to Sunday? Well, if you look at the table there, on Saturday you worked online for 2 hours, and on Sunday you worked online for 4.5 hours. Okay, so let's just talk about that for a minute. You went from 2 to 4.5, so you went up. So this is going to be an increase, okay? Now we're going to use our formula, our amount of change. And this is all, I did this all for you, if you could look at each step that I did. Okay, we have, I'm just going to zoom in there for you. Okay, here we found our amount of change. So I did 4.5 minus 2. That's going to find how much it changed when it went from 4.5 to 2, or 2 to 4.5. Okay, and then you're going to divide that by the original. The original is wherever you started. So in this case, we started at 2 hours, so that's my original, and then multiply by 100. Okay, when you subtract 4.5 minus 2, that's where we got 2 and 5/10, 2.5. And then we divided that by 2, and then we got the 1 and 25 hundredths. And then to just change that decimal to a percent, we're going to multiply by 100 to get our percent of increase, which is 125% increase. Okay, so that is how you're going to figure out percent of change, in this case percent of increase, because we went from a smaller number to a larger number. Let's take a look at the next example. Okay, we have, okay, for example number 2, this table shows the price of gas on May 1st in 2019 and then again on May 1st in 2020. What is the percent of change in the gas prices from May of 2019 to May of 2020? So if you look, in 2019, the cost was $2.85, but in 2020, it was $1.19. So this is going to be a decrease because it went from a higher number to a lower number. Using that same formula, let me zoom in here again. We have our amount of change, which was the $2.85 minus the $1.19. Okay, that's going to find our change. We're going to divide that by the original. The original is the first amount, which was the $2.85, and then we'll multiply by 100. 285 minus 119 gives you the 1.66, And then when you divide by 2.85, you get 58 hundredths. That's your decimal. When you multiply it by 100, you get your percent, which is 58%. And again, that's a decrease because the amount went down. Okay, now let's take a look at the next example. Okay, so for this next one, we're going to be comparing percent of change. Okay, so this is giving you the cost of bread and the cost of eggs in 1977 and the cost of bread and eggs today. We want to know which price had a greater percent of change. Well, first of all, as you can see, they are both percent of increase because they went from a lower amount to a higher amount. So they're both percent of increase. Okay, so let's see which one had the higher percent of increase. Well, first, what I would like you to do is pause the video and find the percent of change for the bread. Okay, you're going to find that answer first. A question's going to pop up, you're going to put in your answer, and then I will continue going over the percent of change for the bread for you. Okay, so to find the percent of change for the bread, we're going to do the amount of change. So the bread went from 25 cents to 2.49, so you're going to subtract those two numbers, okay? You're just finding how much it changed, the difference between the two. And we're going to put that over the original, which is 25 cents. That's where it started in 1977. And you're going to multiply that by 100, okay? When you subtract 2.49 and 25 hundredths, you get 2 and 24 hundredths. Okay, and again, you could use a calculator for all of this. And you're going to divide that by the original of 25 hundredths and then multiply that by 100. Okay, 2 and 24 hundredths divided by 25 hundredths gives you 8 and 96 hundredths. And when you multiply that by 100, you get your percent of change, which is 896% increase. Okay, so that is the percent of change for the bread. Okay, now looking at the numbers before you do anything, you could probably assume which one had the greater percent of change. Okay, well, let's find the percent of change for the eggs. So at this point, you should pause and find the percent of change for the eggs. Okay, finding the percent of change for the eggs, we are going to find our amount of change. So we are going to take $1.99 and subtract 59 cents. And we're going to divide that by the 59 cents is our original amount. That's where we started in 1977. And we're going to multiply that by 100. Okay, when you subtract 1.99 minus 0.59, you get 1.4. You divide that by 59 hundredths. I got a new stylus, can you tell? It's not working. And multiply that by 100. When you divide 1.4 divided by 0.59, you get 2.37. I rounded that. Okay, to the hundredths is always good. And you multiply by 100, and you get 237% increase. Okay, so looking at the prices earlier, like I said, you probably could have determined which one had a bigger percent of increase, but now we found both percent of increases. So the percent of increase on the eggs was 237%. So obviously, which one had the biggest percent of increase? Which again, you may have already figured out before doing the math, but now we know the exact percent of increases. So which one had the greater percent of increase? Can answer that question. The next thing we're going to talk about is percent of error. The percent that an estimated quantity differs from the actual amount. Okay, so you may estimate something, and then you could find your percent of error. Okay, you may hear people talking about this when they are measuring for flooring in a room, or rug in a room, they have a percent of error that they plan for, and they order more of the flooring or more of the carpeting so that they have enough. Okay, because when you're doing things like that, you may have a little bit of waste, so they find percent of error. They use a percent of error. Okay, so we're going to use the formula amount of error, which again is really the difference between what you thought and what the actual is. And you're going to divide that by the actual amount and multiply by 100, of course, because all percents are out of 100. Okay, let's look at this first example. You estimate the length of your bedroom is 14 feet. The actual length is 12 feet. Find the percent of error. Okay, so you're going to use the amount of error, which is 14 minus 12. Okay, what you thought it was 14, but the actual is 12, so you subtract 14 minus 12. And then that gives you 2. And you're going to divide that by the actual amount, and the actual amount of the bedroom is 12. So you divide it by 12. 2 divided by 12 is 0.1666 repeating. Okay, and I left that like that because we know how to write that as a fraction. So when you multiply that by 100, you get 16 2/3% error is your answer there. Okay? So you're, again, finding the difference between the two numbers. That's your amount of error, dividing by the actual amount, because that's the right number. And then you multiply by 100. Okay, so for the next one, I want you to pause the video, and I want you to give this problem a try. Okay, you're going to find the percent of error. The 7th grade math teachers estimated that the class average for the final exam would be 92%. The actual class average for the final exam was 88%. Find the percent of error. So at this point, you should pause your video, give it a try, and then answer the question. Okay, so for percent of error, we're going to find the amount of error. So we're going to take the 92 and subtract 88, and we're going to divide that by the actual amount, which was the actual amount was the 88, okay, and you're going to multiply that by 100. Okay, well, 92 minus 88 would give you 4, divided by 88, and then multiply by 100. 4 divided by 88 gives you, it's non-terminating decimal. I rounded it to the hundredths. Oops, I missed a 0 there. It is 0.045, and it goes on, but that's good enough. Okay, and I did take that out to the thousandths in this case because it's a smaller percent, so I feel like you need to take that out to the thousandths. And when you multiply by 100, you get a 4.5, a 4.5% error. Okay, hopefully you got that correct. Okay. If you have any questions, make sure you write them down, and we will answer them when you ask us. Have a great day.